Okay, in this question and questions like it, there are two methods for answering. The first is by substitution and the second is equating coefficients. Substitution is the one that you're familiar with. It's generally the easiest and I'd recommend you follow that method. And that basically looks like this. So you equate fx to the right hand side expressed as one fraction. Equate the numerators and we get this equation here. So we get this equation here. Now by substituting in different values of x, we say when x is 4, we can see the bracket with the term in a will disappear and the term in c will disappear. So x equals 4 leaves us for this side as well, left hand side, 45 is 9b, we get the answer b is 5. When we let x equal 3, we get rid of our terms with b and c in, and we get a equals 2. And when x is minus 5, we get rid of our terms with a and b in, and we get our answer. So fairly straightforward. I would write out fx again for completion with the values of a, b and c in. Okay, now that's all well and good and generally the preferred method. However, here we're given the condition that x is greater than 4. So if x is greater than 4, our substitutions of x equals 4, x equals 3 and x equals minus 5 can be a little bit dubious. In this particular test in the mark scheme, you were given full marks for this method. However, where there are these conditions, the preferred method would be equating coefficients, which I'll go through with you. It's not as nice. There is more room for error, but because of that condition there where x is greater than 4, it's sometimes preferred. So here we go. For equating coefficients, we start off in exactly the same way with this equation. Now what we need to do is on the right hand side multiply out each set of double brackets, multiply a, b and c across those brackets, and then we're going to group together the terms in x squared, I've underlined in blue, the terms in x, underlined in green, and the constant terms. Grouping those together gives us these, and at this point we can equate coefficients. So I can see I've got 4x squared over here, and on this side I've got b minus a minus cx squared. I've got 1x squared, 1x on the left hand side, and that's my coefficient of x on the right hand side. So equating coefficients gives me these three equations. The first is from the coefficients of x squared, the second coefficients of x, and then the constant terms. So I've got three equations in three unknowns, and your calculator can solve that. So go to solve equations, simultaneous equations in three unknowns, it will give you x, y, z. The reason here I've written a minus a plus b minus c rather than what I'd written up here is because if all of my three equations are in a, b, c, or x, y, z, then I can just plug them into my calculator and write down my answers. Now that's absolutely fine, and do that. Use your calculator to solve them. The mark schemes you will see though give marks for method, so you need to show that you know how to solve them. To do that, take one of the equations over here, for example this first one, and just write it in terms of a equals. So from that first equation for x squared, we get a equals b minus c minus 4. Plug that equation for a into the other two equations and simplify, leads us to two equations in two unknowns with b and c. Solve those as you normally would, and you will get the same answer whichever method you choose. You can see that here. Here's the preferred method of equating coefficients. Method marks for showing that you can manipulate the equations and solve them. We've got our accuracy marks there for A, B and C values. Alternative method shown down here. Again, here full marks, but do practice using this equating coefficients method. Same thing goes for question 5. So here, even if you got full marks on this, have a go at doing this method using equating coefficients. The reason I'm saying that is because you can see we're going to have to substitute an x is 4 to get rid of some variables, and also x is minus 1/3. We'll probably have to substitute x equals 0 at some point. So if we did substitution method, but here I've got this condition that x is greater than 4. So stop the video and have a go at that, see how you get on. We start with our first line where we've got the numerator on the left hand side equal to the numerator of the fraction on the right hand side. Now multiply everything out and collect the terms in x squared, x and the constant. Expand in brackets and then multiplying out by a across through a, b and c. Now collecting the, and now at this point we're ready to equate our coefficients. First of all of the x squared, then of the x's, and finally the constant terms. Plug in this set of equations into your calculator, gives us our answers. A is 4, b minus 2 and c is 6. Do a little bit of extra working to check these. So here I'm going to substitute from the first one. I'm going to write c equals 18 minus 3a and substitute that into these two equations here. I'll simplify. That leads us to these two equations in a and b. Can amend the first one, multiplying that by 4 and then subtract to give. Okay, so that doesn't give me the right answer. That's why it's important to do your calculator before. So go back, unpick, find my mistake. And I found it. It was here. That wasn't a plus b, that should be a minus b as I took things over. So now subtracting those equations gives me minus 2 equals b as expected, with a equals 4 and c equals 6. Again, looking at the mark scheme for 5, you can see equating coefficients in this case is the one that we want, because there is a condition on values that x can take. Okay.